Since the earliest moments of consciousness, humanity has looked up at the night sky and wondered. The darkness overhead, punctuated by pinpricks of light, has been both our ceiling and our invitation, a reminder of our smallness and a call to something greater. Those stars, shimmering across unimaginable distances, have inspired our myths, charted our journeys, and shaped our identities. No matter the era or the culture, the night sky has united us in wonder, in curiosity, and in yearning. It is in our nature to ask, what lies beyond? Can we ever go there? Are the stars truly beyond our reach, or are they the next steps in an endless journey? To understand the challenge before us, we must first confront the scale of the cosmos. The closest star system to our own, Alpha Centauri, is more than 4.24 light-years away. In more familiar terms, that is roughly 40 trillion kilometers, a number so vast that it is nearly impossible to grasp. Imagine the fastest object humanity has ever built, the Parker Solar Probe, hurtling through space at speeds exceeding 700,000 kilometers per hour. Even at this blistering pace, a trip to Alpha Centauri would take over 6,000 years. That is 60 centuries, dozens of times longer than the entire span of recorded human history. And yet Alpha Centauri is just our nearest neighbor. The rest of the stars, the spiraling arms of our galaxy, the glowing clouds of nebulae, and the distant galaxies beyond, recede into distances that defy imagination. It is easy, in the face of such enormity, to feel that interstellar travel is impossible. The numbers seem to mock our ambition, but history is a long story of the impossible becoming inevitable. There was a time when the horizon was the edge of the world, when flight was the domain of birds, and when the moon was a distant goddess. Every horizon we have reached has revealed another, and every impossibility has yielded to determination and ingenuity. Suppose, for a moment, that we could travel at a significant fraction of the speed of light. Let us say 10%. An ambitious figure, but not unthinkable in the realm of theoretical engineering. Even at 10% of light speed, the journey to Alpha Centauri would stretch to 40 years, not counting the time required to accelerate and decelerate. That is nearly half a human lifetime, a daunting prospect, and one that challenges our sense of continuity and identity. How would we sustain such a journey? How would we ensure the survival, health, and well-being of those who make the trip? This is where the concept of the generation ship enters the conversation. Imagine a vessel so large and self-sufficient that entire communities could live, work, and raise children within its hull. An ecosystem in miniature, traveling through the void. The people who begin the journey would not be the ones to arrive. Their descendants, perhaps several generations removed, would awake to the light of a new sun. The generation ship is a bold vision, a floating world, isolated from Earth, and yet carrying its legacy forward. But it is also fraught with questions. How would such a society maintain its culture, its knowledge, its psychological health? How would it guard against stagnation, conflict, or decay? The logistical challenges are immense, but the ethical considerations are perhaps even greater. Is it fair to consign future generations to a life in transit, to a destiny they did not choose? Speed, as it turns out, is a costly ambition. The energy required to propel even a modest spacecraft to a significant fraction of light speed is staggering. Traditional chemical rockets are hopelessly inadequate for such a task. Instead, visionaries have proposed a variety of advanced propulsion systems, fusion drives powered by the same reactions that fuel the stars, antimatter engines harnessing the most potent energy source in the universe, and solar sails, vast sheets of reflective material pushed by the gentle pressure of starlight or powerful beams from Earth. Each concept is dazzling in its promise, but each also confronts us with formidable obstacles. Fusion power remains an engineering challenge we are only beginning to tame. Antimatter, though real, is ruinously expensive and difficult to store. Solar sails require the construction of lasers or energy sources on a scale never before attempted. The technical hurdles are daunting, but they are not insurmountable. They are the next in a long line of problems that, once seemed beyond our reach. Yet even if we build the perfect ship, the challenge of human survival looms large. We are creatures of Earth, born to its gravity, shielded by its atmosphere, nourished by its ecosystems. Space is an environment of extremes, a vacuum flooded with cosmic radiation, a realm of perpetual weightlessness, a place of isolation so profound it is almost unimaginable. The dangers are many. Prolonged exposure to microgravity weakens bones and muscles, alters blood flow, and suppresses the immune system. Cosmic rays and solar storms can damage DNA, increasing the risk of cancer and other illnesses. The psychological toll, the loneliness, the confinement, the monotony, may be the hardest challenge of all. Humans are social beings, wired for connection and novelty. In the vast emptiness between stars, those needs would be stretched to their limits. Time itself becomes a variable in interstellar travel. As a spacecraft approaches the speed of light, time slows down for its occupants, a phenomenon known as time dilation, predicted by Einstein's theory of relativity. For those on board, decades may pass as mere years, while on Earth, generations might come and go. This effect, though subtle at lower speeds, becomes profound as we approach light speed. Communication with Earth would lag by years or even decades. Families would be separated not just by distance, but by time itself. The meaning of home, of continuity, of identity, would be transformed in ways we can only begin to imagine. Despite all these challenges, hope persists. In 1994, physicist Miguel Alcubierre proposed a radical idea, a way to travel to the stars without violating the cosmic speed limit. His concept, known as the warp bubble, envisions a spacecraft that does not move through space in the usual sense. Instead, space itself contracts in front of the vessel and expands behind it, carrying the ship along like a surfer on a wave. Within the bubble, the ship and its occupants would experience no acceleration. From the outside, it would appear to move faster than light. The mathematics is sound, but the practical requirements are extraordinary. The Alcubierre drive would require exotic forms of matter with negative energy, a substance we have never observed, let alone harnessed. For now, the warp bubble remains a tantalizing dream, a blueprint for a future that may yet come to pass. While we work toward these distant possibilities, we may not need to send people first. Recent advances in miniaturization, artificial intelligence, and materials science have made possible a new vision: tiny, unmanned probes capable of interstellar flight. The Breakthrough Starshot project, for example, proposes to send fleets of gram-scale spacecraft to Alpha Centauri, propelled by powerful lasers to speeds of up to 20% of light. These microvessels would be equipped with cameras, sensors, and communication devices, sending back images and data from the edge of another star system. Such missions could be launched within decades, providing our first close-up look at alien worlds, and perhaps paving the way for human explorers to follow. Another promising avenue is the science of hibernation. Research into cryogenics and suspended animation is advancing rapidly. By slowing human metabolism to near standstill, it may one day be possible to send astronauts on journeys lasting centuries, only to awaken them upon arrival. The concept, long a staple of science fiction, is beginning to take shape in real laboratories. Deep sleep, carefully induced and monitored, could protect travelers from the rigors of space and the ravages of time. The dream of sleeping through the stars, once pure fantasy, edges closer to reality. But what if the worlds we find are not ready to welcome us? The process of terraforming, transforming alien landscapes to resemble Earth, offers a long-term solution. We have already begun to contemplate such feats for Mars, exploring ways to thicken its atmosphere, warm its surface, and seed it with life. The same principles, scaled up and refined, could one day be applied to exoplanets in distant systems. Terraforming would be a colossal undertaking, requiring the manipulation of climates, geologies, and ecosystems. It would demand patience, wisdom, and an ethical framework to guide our actions. But it is not beyond the realm of possibility. All these technical questions, however, lead inevitably to a deeper inquiry. Should we go? Is interstellar colonization a noble quest, a moral imperative, or a dangerous escape from our responsibilities? If we leave Earth before solving the problems we have created, climate change, resource depletion, social inequity, do we risk carrying our flaws and failures with us? The stars may offer a fresh start, but they cannot absolve us of our past. Colonizing the cosmos must be an act of stewardship, of humility, of learning from our mistakes. It is not enough to survive. We must transform, grow, and become worthy of the vast universe we seek to explore. Yet, there are compelling reasons to venture forth. Earth, for all its beauty and resilience, is not eternal. Asteroid impacts, supervolcanoes, shifting climates, and the slow evolution of the sun all threaten our long-term survival. Interstellar travel may not be escapism, it may be necessity, a way to ensure that life, consciousness, and the story of humanity continue, even when our home is no longer habitable. The stars are not just destinations, they are lifeboats, sanctuaries, and new beginnings. Beyond survival, interstellar travel speaks to something deeper, our identity as explorers, as creators, as dreamers. Throughout history, we have crossed frontiers, braved oceans, and climbed mountains, not just for wealth or safety, but for wonder, for the joy of discovery, for the thrill of the unknown. Every major leap in our story has begun with a question. What if? What lies beyond? What can we become? The journey to the stars is the latest, greatest extension of that impulse. No, interstellar travel is not impossible. It is hard, unimaginably hard, but it is not closed to us. The word impossible has often been a placeholder for not yet. A century ago, heavier-than-air flight was dismissed as fantasy. 50 years ago, computers filled entire rooms. Today, we carry them in our pockets. We have walked on the moon, sent probes to the edge of the solar system, and begun to unravel the secrets of life and the universe. Each achievement has demanded courage, patience, and the willingness to challenge what we think we know. Perhaps the stars are not unreachable. Perhaps they are waiting for us to solve the puzzles of physics, to summon the will to try, to learn the lessons of responsibility and compassion. The journey will be long, the obstacles immense, but the rewards, discovery, survival, meaning, are beyond measure. In the end, the question is not just whether we can reach the stars, but whether we are ready to become the kind of species that should. The cosmos calls us to grow, to strive, to become more than we are. The stars are not our limit. They are our beginning. They are the next chapter in the story of humanity, a story written in curiosity, in courage, and in hope. So, as you look up at the night sky, remember, we are not prisoners of gravity or circumstance. We are the children of stardust, born to wander, born to dream. Stay curious, stay bold, and never stop reaching, because the universe is vast, and our journey has only just begun.